the log division of numbers, this is what we're trying to do. We've done it before, but let's just say 97 divided by 5. Okay? Now, 97 divided by 5 is an improper fraction, and it's not exactly divisible, which means there is a remainder. Unlike when you have 24 divided by 3, of course, that leaves a remainder of 0. Then we say 3 is a factor of 8. Is that not? In this case also, if you have p of x divided by some function q of x, which is of lower degree, and you can get an exact function h of x without any remainder, then this q is a factor of h, of p. Does that make sense? So for example, you have x squared minus 9 divided by x plus 3. Clearly, you can divide without any remainder. I believe everybody know this. If you do difference of 2 squared, it cancels immediately. Just like if you factorize this, I get 3, 8. I can divide easily. And similarly, x plus 3, x minus 3. So we say this is a factor of this. Alright? So, and we've been talking about this even in the section we have just completed. If it's a factor, it means we can have another factor right beside it that we can factorize. Yeah? Now, in division, what if we don't have exact factor? Okay, how can we write it in form of a mixed number? So in this case, for example, you say 5 divided by this, yeah? 1, then we multiply, then we get a 5, then we subtract, we get 47 by bringing this down. This we already know. And here we say this is 9, 45, then we say, oh, remainder 2. So when our teacher asks us to write this as a mixed number, you say 19 whole number, is that enough? Then you say 2 over 5. Yeah? So similarly, we can have functions that are not exactly divisible. So if you have a polynomial, p of x, and you have a divisor, for example, d of x, of which is not an exact, is not a factor, okay? You're expected to have a quotient. Quotient is this one, okay? Plus the remainder, r of x, still divided by the d of x. Agree? Just like this one, the remainder is still divided by that divisor. Okay? So this is our polynomial or dividend. What you have divided is dividend. This is the divisor, the guy that is dividing it. What you get is the quotient, and what is left is the remainder. That's what this is about. And if you remember our lessons on partial fraction in topic 1, we did this. But we have to just, it's like diverting attention sort of to quickly understand that last part of partial fraction. But this is actually where we need it under polynomial. So quickly, so what we want to be able to do is 2 things in summary. We want to be able to divide polynomials and write rational functions in, I would say, mixed form. Okay? Just like we write fraction in mixed form. So that's how we want to perform. So we don't want to waste time. The division algorithm, we just take examples to do it. Then let's go straight into, look at exercise 5E1, this one. If you want to practice as I do this one. I don't have money for extra computer, I don't need work. You be on your own. First, division algorithm. If you divide a polynomial given p of x as polynomial, okay? If divided by, let's say, d of x, okay? This is the divisor. If divided by this, we get quotients q of x, and that's a remainder. I'm just using this to label them, r of x. So which means your p of x divided by divisor d of x is going to be r of x plus going to be q of x, that's the quotient, plus the remainder, of course, divided by that divisor. And can somebody tell me how to get my polynomial back if all I have is d, q, and r? Leo, you have 30 seconds.
D times q plus r.
That's it. So if I want to get my polynomial back, I'm going to multiply the divisor by the quotient, then I have the remainder. I hope everybody, we all know these are trivial things, so there's no need to waste time. So don't forget this is divisor. We should say this is divisor. Divisor d of x, quotient q of x, remainder r of x. Do you guys still remember how to do division yourself, or do we take one example together as a revision? Or do you still remember how to do it? Come on. If you still remember how to do it, raise your hand. Do you think we should do one together, raise your hand? Okay, let's do one together. So I'm just going to go to the exercise here. So let's just practice. The first question says, find the quotient and remainder of the following. Hence write the division in the form of that. The instruction is in the book, so I'm not going to copy the instruction. Wait, so please, take note of what we're doing. I'm just going to say examples from exercise 5E. That's 1. Alright, so let's look at the first one. X squared minus 2x plus 2x, x squared plus 2x minus 3 divided by x plus 2. Let's check. So you want to write, find the quotient and remainder. Then write the polynomial in that form. Again, this is your polynomial. Okay? This is your divisor. So let's find the quotient and remainder. So we go to the division algorithm. When doing the division algorithm, what we said earlier is you have to rearrange your divisor in descending powers of x. So the highest power comes first. If this is a quadratic, the square comes first. Even if it is given like this, 1 minus 2x minus x squared, you rewrite it as minus x squared minus 2x plus 1 when doing division algorithm. Okay? So here also, you arrange it in that form. And any missing term should be represented by either a space or 0x or 0x squared, something like that. Any missing term. Okay? So what we said earlier, especially those who need the revision, so please look up. We divide the first by the first, we get x, then you multiply everything. Okay? So if you multiply everything, you get x squared plus 2x. Then you subtract. Nothing. You bring down the last one, -3. And clearly, you cannot divide degree 1 by degree 0. So you stop. Okay? So the question says find the quotient and remainder. So your quotient is x. Your remainder, r, or rx. Okay? In this case, your remainder is a number, so I don't need to say rx. And if you write it in the form, the next instruction is write it in this form that Leo told us. Write the polynomial in this form. Therefore, the polynomial itself is the one at the top. X squared plus 2x minus 3. Yes, can someone help me to write it in this form? So, divisor. Yeah. times x, so my x could come first since it's in polynomial. Followed by minus 3. That's it. So that's the form. So this is easy because it's quadratic. Let's move on. These are nothing. Can I ask you to do this in webinar? 2. Divide and factorize numerator into linear factors. So I give you this one. 4x cubed plus 21x squared plus 2x minus 15 divided by x plus 5. 3 minutes, please. Done with 2. Okay. You continue. I just look as you're working. Is the remainder 0 for 2? Okay, good. The first mistake you made was to write there a cube. Yeah, it's a cube, I know, but if you are written a cube, write it immediately. And that's I'm not even talking about this, I'm talking about this one. And that's why it looks like it doesn't make sense. Because they are not the same time, right? Doing that to you and you. Just keep your leg randomly. Nothing. How's it going? So this one has remained a 0, so it's a perfect start. Good. What is the relationship between that cubic function in number 2 and the linear function below it?
The function is a factor.
When you say the function, I don't even know the one you talked about. I put some adjective to describe the function. So you're confusing me.
Like the thing on the numerator?
I call it a thing. It has a name. He feels offended. Just say the cubic function.
X plus 5 is a factor of the cubic function.
Good. You know, when you call people a thing, they have feelings too. Even mathematics have feelings. You never know. We miss a fact. We miss a fact on our Zoom sessions. Come on, I want to see how you do this. So I'm looking. I've seen you. You're still there. You're going to run into trouble like that. You see? They don't look alike. Do they? Yeah. I said something about space. After an x cubed term, what is the next term? What is the next after that? So you have to leave these spaces. Oh, lazy girl. Yeah, it's trivia, isn't it? I think this is some trivia conversation. There's a part of the question that makes it easier. I didn't just include that. Check your answer by expanding this. If I expose this, I already expose the answers for people. That's why I laid that part out. Yes, Leo? Are you confused? I'll tell you why. You probably did a division and you came across something x squared.
Yeah.
So you're wondering, how can I have a cube and x squared, right?
No. It's like I got an ax cubed.
You mean ax squared? No, there's no ax cubed there. Last time I checked. I'm not in your books, I can tell you that's not what you meant. No?
I wrote ax cubed.
You're not supposed to have that. What's your divisor? X plus 8. What's your dividend?
Plus a cubed. Oh.
Because a cubed is a constant. Alright? A cubic function has 4 terms. The constant is the 4th one. So you need to put zeros for the rest because, you know, the fact that they are not in the apartment doesn't mean you take over it. They can come at any time. Is the apartment not yours? Is that how parent takes over people's stuff? It's your apartment, not yours. Okay, so please leave the spaces and everything will make more sense. Mr. B, you understand what I mean now? Yeah. That's why I keep saying, if a term is missing, reserve the space. Alright, let's have 2 more minutes to wrap that up. The next set of questions I'll be writing is about unit 4. Miss B, is this place covered?
Not at the moment. No, it is.
It is. Okay, how about that? Because I'm going to take some parts off.
Yeah.
Everything is
They were
good.
both
Alright. So I'm going to erase this and this. That's the reason I'm asking.
Yeah.
So you can just focus on the last part for now. Thank you. Alright, quickly. Please pay attention to what you're doing. You still need this in calculus. Okay? If you want to integrate some rational functions, you may end up using partial fractions, and to understand that properly, you need to learn to divide properly. So it's not just for this topic alone. It's useful even in subsequent topics. So I'm interested in your answers for number 3. So while I'm waiting to go around to check if you are done with your work, please proceed with question 4. So again, this is find the quotient and remainder. From this section, it's actually from exercise 5.2. So okay? Page 123. By the end of this week, I want us to be done with polynomials. So please, learn to work faster and work together. have 2 minutes. We have 2 minutes. Okay, everybody, please listen to this. Let's make sure that everybody is on the same page here. I think the rest are trivia. Okay, you can do one together, then you can sort out the rest on your own. Okay, so for this one, x divided by this, what do we have? Quickly. When you multiply back, x cubed, ax squared. That's why some of you were confused, because you had your a cubed here. If you subtract, this is gone, 0. And this is negative ax squared. So I bring the next one, 0x. You can write everything out, but you can write only the next one. Worst case scenario, you multiply the next and you need an extra space, you quickly bring down the term. Okay? So for example, if I do not write it, then I divide the next one. I get minus ax, right? So when I multiply back, minus ax squared, minus ax. Then I quickly remember, oh, I should have brought this down, plus 0x. Okay? And when you subtract, this minus this, because they are exactly the same, replica, that's 0. Now this is 0 minus minus a. You have to be careful. And that will be plus ax.
That should be
A squared.
Which one? Oh, my bad. Maybe I didn't get enough sleep. According to the cat lady. Okay, so you did the last one. What do we have? Plus a squared. And multiply a squared x plus a cube. And if you bring this down, you get your plus a cube and everything is 0. Okay, so it says n's factorized. Before we could factorize, it actually means from here, okay, 2 or b first. What this means from here is that your x cubed plus a cubed is actually what? X plus a, x squared minus ax plus a squared. So you have to use this to factorize. I'll just do the second one. X cubed plus 125. What does that say? A is equal to 5. So just replace a is equal to 5 here. Alright? So this simply means, there's no need for this step. I'm just writing it. So simply means x plus 5, x squared. Yes, help me out.
Minus 5.
And 5. That's it. N's means based on your previous result. Yeah? So, this one, we've talked about it. You continue to divide until the degree is less by 1. Okay? So, for here, you have x squared. Like I said, the divisor must be written in the descending powers of x or y, depending on what the variable is. X cubed, 2x squared minus x minus 3. So let's go. The first one divide, we get x. Then what? Oh yeah, thank you. Then we multiply x cubed, x squared plus x. What do we notice here? 0, 0, or we have x squared. Then we have negative 3. Okay, so can we still divide? Yes, because this is squared, this is squared. You only stop dividing if this is lower. When they are still equal degree, you continue. Yeah? So this will be 1 x squared plus x. Now, because this is a vacant space, well, the owner might